Avionics ventilation is an automatic system that provides cooling to the electrical and electronic components in the avionics compartment and on the flight deck. The items that are cooled by this system include the instrument and circuit breaker panels. Two electric cooling fans are used to provide the necessary airflow. A system of valves operate to direct the airflow for various configurations. The configuration is normally controlled automatically by the Avionics Equipment Ventilation Computer, or AEVC, but may be controlled manually by the blower and extract push buttons on the ventilation panel during abnormal operations. For normal operations, these blower and extract push buttons are in the auto position and all lights are out. For abnormal operations, one or both push buttons will be selected to override as directed by ECAM. During this module, we'll refer to skin temperature thresholds for on-ground and in-flight operation of the avionics ventilation. The two thresholds are shown here and are available for reference throughout this module. Depending on the skin temperature, the cooling air is provided by outside air, circulated air in the pressurized portion of the aircraft, or by the air conditioning system. The configurations we'll describe in this module are shown on this frame. We'll begin with normal operations and we'll describe the open circuit configuration. The open circuit configuration is the normal ground configuration and operates only if the thrust levers are not at takeoff and the skin temperature is above the on-ground threshold. We would expect to see this configuration during mildly cool, warm, or hot ground operations, and it is not available in flight. The AVEC will select the configuration to the closed circuit configuration on the ground if the skin temperature is very cool or cold. This open circuit configuration diagram shows that outside air is pulled through the open skin air inlet valve by the blower fan and then moves through the avionics equipment. The extract fan pulls this air and conditioned air from the cockpit panels and blows it overboard through the skin air extract valve. All other valves are closed in the open circuit configuration. The closed circuit configuration operates while the aircraft is on the ground, thrust levers not at takeoff, and the skin temperature below the on-ground threshold. This is the operation that we would expect to see during very cool or cold ground operations. Also, the closed circuit configuration is the normal in-flight configuration and during flight operates if the skin temperature is below the in-flight threshold. The AVEC will select the configuration to the intermediate configuration if the skin temperature is above this threshold, above average, hot in-flight temperature. This closed circuit configuration diagram shows that air is circulated with the skin air inlet, skin air extract, and air conditioning inlet valves closed. The air from the avionics bay is pulled by the blower fan from the skin exchange outlet bypass valve through the avionics equipment, and then the extract fan pulls this air along with cockpit conditioned air into two areas. Notice that the skin exchanger inlet bypass valve and skin exchanger isolation valve are both open in this configuration. The air from the extract fan is recirculated through the skin heat exchanger for improved cooling, and some of the air from the extract fan is delivered to the underfloor cargo area for ventilation. The intermediate configuration provides ventilation when the aircraft is on the ground with takeoff power, or during in-flight if the skin temperature is above the in-flight threshold. The only difference between this and the closed-circuit configuration is that a smaller internal door flap opens on the skin air extract valve to allow some of the air to flow overboard. This completes the normal configurations of the Avionics ventilation system. Now we will describe the two abnormal configurations for this system. An abnormal configuration that is very similar to the closed-circuit configuration operates if the blower fan or extract fan is shut down. This configuration will be set by the crew as a result of an ECAM procedure. With only the blower push button in override, the blower fan stops and the air conditioning inlet valve opens to supply cooling air. With only the extract push button in override, both fans continue to run and the skin exchanger inlet bypass valve closes to force all recirculating air over the skin heat exchanger. Another abnormal configuration is set when smoke is detected in the Avionics ventilation air. The detection of smoke will cause both the blower fault and extract fault warning to occur. The smoke configuration is set by the crew as a result of selecting both blower and extract push buttons to override. The blower fan stops, but the extract fan continues to operate. All valves close except the air conditioning inlet valve, and a smaller door flap opens on the skin air extract valve. This configuration purges smoke from the system by using conditioned air to blow through the Avionics equipment and then overboard through the smaller internal door flap on the skin air extract valve. Finally, a variation of the smoke configuration is set if the Avionics equipment ventilation computer fails. However, the skin exchange isolation valve remains open, the inlet valve and skin exchange inlet bypass valve remain in their last position, and the extract fan continues to operate.